Hi all, this is part 3 of the React Native animated series. If you haven't watched the earlier videos, I will link the playlist in the description. In this video, I will be speaking about the interpolate and extrapolate. So, what is interpolate? In short, an interpolate maps input ranges to output ranges. Suppose we want a box to animate its background color when moving from left to right. We can understand this from this graph. This graph shows the relation between the credit points on the y-axis and the year on the x-axis for a particular person. In year 2020, that person got suppose 4 points. In year 2022, he or she got 10 points and so on. Now we can predict that in between 2020 and 2022, that is for the year 2021, he or she should have got around somewhere in the middle like 8. So we have predicted this value 8 by taking a middle between 4 and 10. So this is not the exact credit point by the person, but we can predict this with the help of these two data points. So here year, which is on the x-axis, is the input range, and points, which is on the y-axis, is the output range. Now speaking about interpolate in React Native, suppose we want to animate background color of a box when moving from left to right. Here the position of X is our input and the background color is output. Now let's understand in code how we write interpolation in React Native. I have created a simple component in which there is a box and two buttons, start and reset. You can pause this video here, or I will add a link for the GitHub commit of the starter code in description. So this is the initial code. There is a component card color interpolate, and on start and on reset. I have not coded these functions yet. Now there is a view, and inside this there is this box, this green colored box. There is a button group which wraps around these two buttons and align them in a flex direction row. So this is the style. Okay, the functionality that we want is on press of the start, the box will move from left to right, and at the same time the background color of this box will change. Suppose at point 0 it will be green, and at point 300 it will be yellow. Now since we will be tracking a single value x-axis, we will use the animated dot value. I will import the animated from React Native. Now let's write on start function. In this example, our true value will be 300. So we will use the animated.timing function. Suppose we want this animation to happen in 5 seconds. So we will set our duration to 5000 milliseconds. And then we start. Now on reset will also be similar, except we will change this two value to 0, and there is not a need of duration. It will be 0 and we can remove this. Now let's first move the box from this position to this position. So for the box, now every view we have to use is animated. Okay, it will be 300. Okay, so it has reached this 300 point. Now we need to change the background color to yellow when it has reached here. Now in order to interpolate, we will call the interpolate method of this animated value box position. So let's start the code. Background color will be based on this box position. We will call the interpolate method. This will take in an object with two mandatory keys, input range and output range. So input range is 0 to 300 and output range will be green to yellow. Now React Native will automatically animate the values between these 2 points. So suppose 120, what will be the value? React Native will automatically determine based on this green to yellow transition. Let's run the code to see the UI. I will press on the start button. See, the box is moving forward and the background color is also changed. Let's introduce a third point between 0 to 300. Suppose we introduced middle 150 and the color at this point is blue. I will again press reset and then start. Okay, now let's also animate the opacity. We will change the opacity such that in the start and in the end the opacity will be 1, but in the middle it will be 0.5. For this we will also use the same animated box position, this one. 0, 150, 300 and output range will be 1, 0.5 and 1. I will press reset and then again start. Let's see the animation again. See, at this point the opacity was very less. So I will commit this code. There is one disadvantage in using the interpolate in this way. Suppose we want the width of this box to increase as per this animated value. Let's start the code width and this will be similar to here. 0 to 150 we can take is also 0, 150. We can comment out this code and this will be green and hard code it. I would just want to highlight this issue and transform we can also comment. So if I press on reset, see this error, style property width is not supported by animated module. This error is in general thrown for layout properties. Like whenever we set interpolate on layout properties like width and margin, then we will get this error. A fix for this is to set use native driver to false. So let's restart the code. See, it is working. It runs fine now, but the performance is now less as the animation is now running on the JavaScript thread rather than on the UI thread because we have set the use native driver to false. To permanently mitigate this, we can use the third-party React Native reanimated library which renders it in the UI thread. I will try to create a separate video on using that library. Now let's commit it. Now let's move on to the extrapolate. So I will go back to this slide. Extrapolate is simply estimating the output values beyond the input range. If we saw this graph, if we need to find the point before 2020 and after 2026, by plain estimation we can say that for 2019 it will be around 3 and for 2027 it will be around 40. So React Native does a similar kind of estimation. React Native provides three types of extrapolation to set this output range. The first one is extend, another one is clamp, and the third one is identity. Let's go in the code and see what is the difference between them. So let's revert the earlier styles, and we don't need this width. So since we are not using width, we can set the use native driver to true. Let's give it a restart. Okay, so it is working. Now to understand extrapolate, let's bring in another transform style scale. The size of the box will grow as it moves from 0 to 300. Now we can comment out this opacity and input range suppose 0 to, so our animation is ending at 300, but we will do scale up to 150, and output range, since the scale is for the size, I will set it from 1 to 3. Restart it, so it is growing. The first type, extend, means that React Native will continue the interpolation beyond this range. If nothing is mentioned, then React Native will continue the interpolation beyond this range also. That is the default. So that's why we see that, see, even after the 150 point, it is still scaled. If we set clamp, then after 150, the output range will be clamped to 3. It will not grow. Now the box does not grow now. Earlier the box was very large. One point to note is that we should be careful in using the extend, as this might lead to unexpected value. So as we see that even if we don't set the scale, then also it is growing. So mostly we will try to use extrapolate clamp. Now another thing is the extrapolate identity. What this identity sets is beyond this point, the output range value will be the input range. Beyond 150, the output range, since it's not mentioned, it will be 150. So now if we start the animation, see, it suddenly becomes, the scale of the box becomes 150, so it went beyond the screen. But mostly we will be using extrapolate plan. Now let's go back to the slide. I have created this graph on knowing the difference. Input range is from 0 to 300. Output range is 1 to 3. We have not considered this point in the interpolate. We have only given input range up to 150. Now for extend, React will automatically determine what will be this value. For clamp, this will be clamped to this point itself. For our case, it will be 3. And for identity, it will take this input range value. So at this point, it will be 150. So these are the various types of extrapolate available to React Native. Now let's commit this code. One more point related to extrapolate is there is a extrapolate left and right, where we can set this extrapolate value explicitly for left and right separately. Like we can set extrapolate left to clamp and extrapolate right to extend depending on our scenario. The last part of this video is regarding the easing function. Let's look into the easing functionality in this animation. So we can set the easing function by using this easing property. But one thing to note about this functionality is if we provide this property, we have to set the useNativeDriver to false as it is not supported. So we will set this to false. Now we don't need this extrapolate. So easing takes in a number and will return the output value at each point. So this is the default because it is a linear. We can set our own easing functions. Suppose we can give math.pow t comma 3. So this is a exponential function. This extrapolation happening is of extent, so that's why. But let's set this to clamp. Let's start the animation. The box is also translating. Let's stop that. Okay, now it is growing. Now if I set it to another one, easing dot bounce. So for that I will import the easing module. And the bounce will be suppose t. See, there will be a springy animation like this. So let's commit it. So that is it for this video. In the next video probably we'll be developing some animation components. Thanks for watching.